Hey everyone, welcome back to the channel. Today we are going to explore different concurrency patterns in Go and break down how you can use them in your projects to make your code more efficient and scalable. So as you can see on my screen, the title Types of Concurrency Pattern in Go. Go concurrency model is one of its most powerful feature, and understanding how to use concurrency patterns effectively can help you tackle complex programs more easily in Golang. So before diving into specific patterns, let's quickly cover what concurrency means in Go. Concurrency in Go is handled through Goroutines, which are lightweight threads managed by Go's runtime, and channels, which allow Goroutines to communicate with each other in a safe manner. So we need Goroutines. Okay, so Goroutines allow you to run functions concurrently, and channels help synchronize and communicate between these Goroutines. With that said, let's dive into some common concurrency patterns you will likely use in your Go programs. And I should write second one also here, channels. Okay, so we have the first pattern, which we call fan out fan in. So let me write it. So fan out fan in pattern, when we have multiple Goroutines that handle parallel tasks and then greater their results into single Goroutines, this pattern is often used when processing multiple items like task in a queue. Okay, so we will try to understand it with the help of a simple example, which we will code out it here on the screen. Okay, so let's try to implement those. So we will be using weight groups here. So package main import fmt sync, and we will close it. Then we will make one function worker, and that would be having an id of type integer and channel of type integer. Then we have one weight group, which will be declare it like sync dot weight group, and we will close it, and we will close the weight group by using wg.done method, and will pass the id to the channel. It's a very simple program. Now we will be writing main function for this one, func main. We will declare initialize the channel, which is ch shorthand declaration make channel of type int. We will declare weight groups by wg, that is sync dot weight group. Then we will create one loop for I is equal to 0, I less than or equal to 5, I plus plus. We will make Goroutine here, so we need to add the counter first, wg dot add 1, and we will run the Goroutine function which is go worker, and I ch and operator wg, and we will now create one more function that is go function, simple, without any arguments passing, which will do wg dot wait for the counter and close the channel ch. Okay, now we will print the output for id range ch, then fmt dot println, we will be saying receive id. Okay, so this line number 18, which is basically showing the fan out procedure, which is spawning the Goroutines. Okay, and this line number 24 is performing fan in procedure, which is collecting the results. So I will comment it out for better understanding. Fan out, okay, that is, and this is fan in. Okay, so we can see in this example, in line number 20, we are spawning 5 Goroutines to stimulate our work, each sending its result to the same channel, okay, which we have declared in the function worker. The main Goroutine collects the result, demonstrating how to fan out tasks and fan in their results. Okay, I hope you have understood. Fan out, they are populating the 5 times the add counter, and it is being run 5 times, and fan in is collecting it at the same time. Okay, so we will run it. Okay, must be a function call. Okay, I need to add this. See, okay, that is fan in, fan out, our first concurrency pattern. Now we will be having the second one, which is worker pool pattern. Okay, so let me write worker pool pattern. So in worker pool pattern, which is particularly useful when you want to limit the number of concurrent tasks, even though you may have many jobs to process. Okay, by using a worker pool, you can control the number of Goroutines that are running concurrently. To make it more clearer, let's dive and see with the help of example. Okay, so similarly, package main import fmt, and also we will have sync package. Then we will similarly make worker function id integer type, and we will have jobs which will be of channel integer type, and result chat integer receiving type. Okay, so here in this work function we have jobs, sending, channel which is integer type, result is the receiving one. So for job in range jobs, okay, which is the receiver one, fmt, sorry, I need to fmt dot print ln worker dash percentage t processing job %d and new line we need two values, that is id and job. Okay, result is job into 2. Okay, now we will write the main function for this one. Func main and we would be similarly like previously create one jobs which will make it channel of type integer, and we will specify the capacity. So if we specify the capacity, it is a buffered channel. Okay, results similarly make channel of type integer and capacity is 5. Okay, variable wg sync dot weight group for I equal 1, I less than equal to 3, I plus plus, then we will increase the counter by 1 every time, and we will perform go func I of type integer, and we will be doing defer to close the process of weight groups once it's done, and then will be worker which will be I, jobs and result. Okay, enter, and we would be having a receiver argument 1. Okay, this is all about creating the worker. This function from 23 to for loop from 23 to 29, that is for creating the workers. Now we will be sending the jobs to these workers. Which is for j 1, j less than equal to 5, full the capacity j plus plus, and we will open the brackets and we will send jobs, we will send j to jobs. Okay, now we have to close the jobs, otherwise it can go under panic. Oh no, job should be closed here. Okay, now we have to receive this results, so we will be needing new go function, go routine to receive is. So go results and we will have wg dot wait close results, and to print this results we need a loop. Okay, so for results in range of what? Range of results. So both the variable cannot be same. fmt dot println result is result. Okay, I hope it's now done. If I run it, so we have okay, it should be go func, not go results, because it's a function. Okay, wg dot wait okay. I need to check what is wrong in line number 12. So we need we don't need a new line, we need we are using percentage, so it will be in format. Yeah, you can see work on 1 processing job 1, work on 1 processing job 2, and similarly 3 4 5, the result is 2 4 6 10. Okay, so in this pattern we have 3 worker goroutines handling jobs, okay, which you can see here, creating the workers, and the main function send jobs into the jobs channel. Okay, this one, the sending jobs from line number 32 to line number 37, and the workers process them in parallel. This allows us to process jobs efficiently with a limited number of workers. Okay, so this is the one worker pool pattern. Now we will see the next one, which is my personally favorite, publish and subscribe problem. Okay, we can call it as a problem or a pattern. So publish, subscribe, okay, pub sub we can say. So this concurrency pattern, which is also known as pub sub, this is especially useful in event-driven systems. In this pattern, one goroutine sends messages and multiple goroutines listen for those messages and react accordingly. Okay, let's code it out and try to understand. So package main import fmt, and we will need here time, no sync package, because there will be no need to handle concurrency. We'll create one struct. Okay, the struct will be type of subscriber, and the struct will be having an ID, because each subscriber would be having an ID. So subscriber, okay, and it would be of type struct and ID int. So func, what the receiver variable, which is s, and subscriber pointing to the struct. Then we have a receive function which is having channel and receiving channel of type string. Okay, now what to do? Now here will be the receiving. So receiving would be in the form of string and channel, receiver channel. So we can iterate from this channel ch. Okay, so for message we can have range of ch, and we can print it as fmt dot print f. We will be using here %d. So subscribe %d received this message in the form of string, so that is string %s. Okay, so this would be s dot id, that would be from structure, and this is message. Okay, which is basically a string. So this is the subscriber function which we created. Now let's write the main functions. So how we can proceed, or we can say that we can make this main function. So we need the first declaration itself would be from the function receive, which is a channel of type string. Okay, so let's code it. Func main. So we can name it sub publisher make and channel of type string. Okay, we got one declaration, and also we need subscribers. Okay, so we need to create subscribers, so we will be creating 2 subscriber here. Okay, so let's create sub1, which will be an receiver subscriber. Okay, so subscriber, and it would be having an ID of 1. So what is this pattern you try to understand is if we have study structures, this is how we assign the values to the structure. Okay, so similarly we are assigning it. So we have save2 and operator subscriber ID is now given as 2. Okay, now we have to write one go function, which is Goroutine, for publishing the message. Means the publisher will be sending the message, which will be in the form of IDs. Okay, we can set numerical value. So let's see how to write it. Go func, here is the function, for I is equal 0, I is less than 5, I plus plus, please send this message to pub. Okay, what to send? Format s print f, I should comma, s print f okay, and message %d, and it would be an I. Okay, so we are not using wait groups, so you can use time.sleep to make the main function to wait for it. Main function to wait for the Goroutine function, which is in line number 24. So time.second okay, so and the another rule is close the channel, which is close, not would, it should be pub. Okay, so this is done, and it's an go routine. Now this will, I think if we try to run it, so new line is a string in line number 16. Okay, what I need, I'm missing it. Okay, I need to put this one, declared but not used. What we have not used, sub 1, sub 2. Okay, okay, we are missing something here. We need to start to listen the message also. So we are creating a go routine, go sub 1 dot receive. We have not called the function. Receive, and it will be having pub. Same for go sub 2 dot receive pub. Okay, now let's run it. Okay, see this one, this program is exited. Why? Because we don't have anything in the main function to wait for the program. Okay, means we need time from the main, we need to make the main function to wait for some time to get this go func to run in line number 27. So to get the results, what we can add one line, which is time dot sleep for 6 seconds. I'm taking 6 seconds, you can take anything. Time dot second. Okay, now let's run it. Okay, see program exited. Okay, so we get which message went to the which subscriber. Okay, so we have a publisher that sends message to the pub channel, and 2 subscriber receive the message and react. This pub sub pattern is a perfect for scenarios where multiple components need to listen the updation of the events. Okay, so I think this would be clear to you, and this can be asked in the interviews, the pub sub problem in Go. Okay, now we will come to the last pattern, which is basically a rate limiting. This pattern you can use basically in APIs while working in Go. So this concurrency pattern is useful when you need to limit the number of operations of tasks happening within a specific time window. Okay, so let's try to understand this also with the help of an example. So we have rate limiting. Okay, the next pattern. So this should not take much time. Let's code it out first. Package main. Here also we don't need wait groups, so we will take the help of the time package fmt time. Okay, now func main, that is we will create one variable of type limiter, this time dot take to time dot second. Okay, for every one task we have to limit the time to 2 seconds. Okay, that is, it is should not take more than 2 seconds. So I will comment it out so that you can understand. Limit to one task every 2 seconds. Okay, for one task we have to give 2 seconds. So we'll create one loop for I is equal to 0, I is less than or equal to 5, and I plus plus, and then we will receive this limiter, okay, which will be now printed into fmt.print format, not ln, and we can show here like task %d executed, new line, and I, the task which is being executed. Okay, so time.take is a method like time.sleep, which you can see from Go documentation of time package, which is basically limiting the one task for every 2 seconds. Like we are using time.sleep, which is basically silencing or can stop the execution of the main function for the amount of time which we have given in the program. Okay, so let's run this. Unexpected name I in the argument. Okay, so where is the I? Okay, I should be having a comma here. Task 0 executed, 1 executed, 2 executed, 3, 4, and 5. Okay, so what is happening? We have created a rate limited using this one, which is line number 11, time.tick, which generates a tick every 2 seconds. Okay, you are seeing the outputs being printed in every 2 seconds gap. The main coroutine waits for each tick before executing a task here. Okay, this helps prevent overloads by limiting how often the task can run. Okay, this is the main function. So that's it. We have covered several key concurrency patterns in Go: fan out, fan in, worker, pool, publisher, subscriber, and rate limiting. These patterns are essential for building scalable and efficient concurrent systems. So if you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you won't miss any of our future videos. And if you have any questions or suggestions for future topic, leave a comment below, and happy coding. See you soon in the next video. Till then, bye bye.